When you look at the night sky, you're not just looking into space, you're looking into the past, and much of what you see may already be gone. The question is, how much of our universe is already dead? Chapter 1. The Illusion of a Living Sky. On a clear night in the Atacama Desert, the sky feels endless. Above you stretches a black ocean, pierced by millions of points of light. The air is thin and still. No city lights, no haze, no sound, only the steady, quiet breath of the earth beneath your feet. You look up, and every star seems alive, burning fiercely in the dark. But the truth is, many of those stars have been dead for millions of years. What you're seeing is not the present, it's the past. Light takes time to travel. The sun's light needs just over 8 minutes to reach us. The light from Sirius takes about 9 years. The glow from the Andromeda galaxy has been traveling for more than 2 million years. When you look up at the sky, you're looking at snapshots frozen in time. You're not seeing the universe as it is now, you're seeing the universe as it was. That means some of the stars still shining in your eyes have already burned out. They've collapsed into cold remnants, or exploded into supernova, scattering their elements into space. But because their last light is still racing toward us, they appear unchanged. In a way, we are surrounded by cosmic ghost stars, whose final moments passed long before life on Earth even existed. This idea changes the way you think about the night sky. It's beautiful, yes, but it's also a reminder of distance, time, and impermanence. The sky is a gallery of the past, painted in light. It invites you to wonder, what does the present-day universe really look like? If we could step outside the limits of light speed and see the cosmos live, how different would it be? Astronomers have spent decades trying to answer that question. They use powerful telescopes to peer deeper into space, which is the same as looking further back in time. The Hubble Deep Field, for example, revealed galaxies from the early universe, barely formed, glowing faintly in the black. On the other end of the timeline, researchers study galaxies closer to us ones, whose light has traveled only tens of millions of years, to see how they've aged. The picture that emerges is strange. The universe is not equally alive everywhere. Some regions are still busy creating stars. Others are quiet, with only the cold embers of ancient suns. Astronomers call these quiescent galaxies. They've stopped making new stars entirely. In these places, the night sky is dim, and the future will be darker still. But to our eyes here on Earth, the differences are hidden. The light from active galaxies and dead galaxies alike blends together, giving the illusion of a vibrant, uniform cosmos. The truth is layered beneath millions and billions of years of travel time. Consider this. The Milky Way itself has stars of many ages. Some are newborn, just a few million years old. Others are nearly as old as the universe itself, around 13 billion years. Many of these ancient stars are nearing the end of their lives. Yet from Earth, they shine side by side, giving no clue to the vast gulf in their histories. The Atacama Desert is one of the best places on Earth to experience this illusion in its purest form. At night, the Milky Way cuts across the sky like a river of light. You can see the Magellanic Clouds, 2 small galaxies orbiting our own. You can spot the faint glow of the galactic center. It all feels so immediate, so present. But even the nearest parts of that glow are thousands of light years away. This is why astronomers say that observing the universe is like archaeology. You can't see the present, you can only see the record of the past, preserved in light. Every photon carries a and because the speed of light is finite, we are always looking backward. It's a humbling thought. The sky you see tonight is not the sky as it is now. Somewhere out there, entire constellations may already be gone. New stars may have formed in their place, but their light won't reach us for tens of thousands of years. The living universe is hidden behind a curtain of time. And yet, there's comfort in this. It means the light from stars, even in death, can travel vast distances to reach new worlds. It means that for countless nights to come, we will still see the glow of suns long gone. It's a kind of immortality, written in light. For us, standing on a small blue planet, the illusion of a living sky is both a gift and a mystery. It inspires poetry, science, and the desire to know more. But it also leads to a deeper question: if what we see is already the past, how much of the universe we think is alive has already died? That question takes us deeper, beyond the simple beauty of starlight, into the science of cosmic death. To understand it, we need to look not just at stars, but at the life cycle of the universe itself. And that is where our journey continues. Chapter 2. The Science of Cosmic Death. Every star you see in the sky is part of a larger story, a life cycle that begins in clouds of gas and dust and ends in silence. To understand how the universe might be dying, we first need to understand how its stars live and die. A star is born when gravity pulls together massive clouds of hydrogen and helium. As the gas collapses, its center heats up until nuclear fusion ignites. This process fuses hydrogen into helium, releasing light and heat. For most of a star's life, this fusion keeps it stable. It pushes outward against gravity, holding the star in balance. But fusion cannot last forever. Eventually, a star runs out of fuel. What happens next depends on its size. Small stars, like our Sun, will expand into red giants, shed their outer layers, and leave behind a white dwarf, a dense, hot core about the size of Earth. White dwarfs slowly cool over billions of years until they become dark, cold objects. Massive stars live more violently. When they run out of fuel, their cores collapse in seconds, triggering a supernova, an explosion bright enough to outshine an entire galaxy for days or weeks. The remains of these stars can become neutron stars, so dense that a teaspoon of their material would weigh billions of tons, or black holes, objects so compact that not even light can escape their gravity. This cycle of birth and death shapes the universe. Supernovas scatter heavy elements like carbon, oxygen, and iron into space elements that become the building blocks of planets and life. In that sense, star death is also star rebirth. But over time, something changes. Stars need raw material, gas and dust, to form. In the early universe, this material was plentiful. Galaxies were like bustling cities, constantly building new stars. But as billions of years passed, much of the available gas was either locked inside stars or blown away into intergalactic space. In many galaxies, star formation slowed, then stopped entirely. Astronomers call these quiescent galaxies. They are still home to billions of stars, but no new stars are born. Over time, their existing stars will burn out, leaving only cold remnants. Slowly, these galaxies will fade into the dark. On the largest scale, the universe follows the same logic. The second law of thermodynamics tells us that entropy disorder always increases. Energy spreads out, heat dissipates, systems run down. Applied to the cosmos, this means the universe is slowly moving toward a state where energy is evenly distributed and no work can be done. This is the heat-death scenario. In that distant future, there will be no bright stars, no warm planets, no life. Black holes will dominate, and even they will eventually evaporate through Hawking radiation. The cosmos would be cold and empty, a vast, silent expanse. But here's the strange thing. The seeds of this fate are visible today. Astronomers using telescopes like ALMA in Chile can see galaxies in various stages of life and death. Some are vibrant, filled with blue, young stars. Others are dim and red, with no new stars forming. This patchwork view tells us that the process of cosmic death is not a single moment. It is a slow, uneven decline happening all around us. It's tempting to imagine the universe as a single, living organism, now past its prime. In some regions, the lights are still on. In others, they have already gone out. From our place in the Milky Way, we're lucky. Our galaxy is still forming stars, though at a slower rate than in its youth. We're not yet in the twilight, but we're closer than we think. Understanding this cycle isn't just about predicting the far future. It's also about appreciating the fragile window we live in. We exist in a time when the universe is still bright enough for life to thrive, but old enough to carry the history of countless generations of stars. The balance is temporary, and this raises a haunting question. If the universe is heading toward darkness, what does that mean for everything in it, including us? To explore that, we need to look beyond individual stars and galaxies and consider the forces shaping the cosmos as a whole. That's where we begin to see the signs that the universe's slowdown is already underway. Chapter 3: Signs that the universe is slowing down. If you could stand still and watch the universe for billions of years, you might notice something subtle, like the way a once bustling city slowly quiets down. Streetlights go dark one by one. The noise fades. The air grows still. In the cosmos, this quieting is happening on a scale so vast, it's almost invisible to us, but with the right tools, we can see it. One of the clearest signs comes from the galaxies themselves. Not all galaxies are alive in the same way. Astronomers divide them into two main categories: blue, star-forming galaxies, and red, quiescent galaxies. The blue ones are bright, energetic, and full of newborn stars. The red ones are older, places where star formation has stopped. When telescopes like the Hubble Space Telescope and ALMA, the Atacama Large Millimeter-Submillimeter Array, peer deep into the night sky, they aren't just looking across space, they're looking back in time. The farther away a galaxy is, the longer its light has traveled to reach us. Some of the galaxies we see are as they were billions of years ago, when the universe was young. This cosmic time machine shows a striking pattern. Billions of years ago, the universe was full of blue galaxy star factories churning out new suns. But in more recent epochs, red galaxies have taken over. The rate of star formation has dropped by about 90% since its peak. That's not a minor slowdown. It's a massive shift in the energy of the cosmos. Another sign comes from the cosmic microwave background, the faint afterglow of the Big Bang. It's like a whisper from the universe's earliest moments. Detailed measurements from satellites like Planck reveal that the cosmos is expanding faster than expected. This accelerated expansion is driven by something we call dark energy, a mysterious force that makes up about 68% of the universe. Here is the paradox. Dark energy is both the reason the universe won't collapse in on itself and the reason it may die faster. As galaxies move farther apart, the raw material for star formation becomes more isolated. Gas clouds can no longer clump together as easily. Starbirth slows. The universe's lights begin to fade, not because of a sudden catastrophe, but because of a slow, inevitable drift into separation. We can also see hints of this slowdown in specific places. For example, the Atacama Desert in northern Chile is one of the best places on Earth to observe the sky. Its thin, dry air and lack of light pollution reveal stars in dazzling clarity. Astronomers there can detect ancient, distant galaxies that are no longer forming stars. These are cosmic graveyards, beautiful but silent. Even within our own Milky Way, the change is visible. The galaxy is still forming stars, but at a fraction of its past rate. Some regions are already dark, vast stretches where no new suns will ever shine. In a few billion years, the Milky Way will merge with the Andromeda Galaxy. That collision will spark a brief wave of star formation, but it will be the last great burst before both galaxies settle into quiet old age. The deeper we look, the more the evidence lines up. Fewer young stars in nearby galaxies compared to the distant past. An increase in dead galaxies, those with no active star formation. A steady decline in the cosmic star formation rate over billions of years. These aren't random events, they're pieces of the same puzzle. They tell us that the universe's most creative era is behind it. What we're living in now is a middle chapter, a time when stars still shine, but the pace of creation is slowing. And yet, there's something poetic about this. The light we see from distant galaxies often left them millions or billions of years ago. In some cases, the galaxy itself may be long dead, but its light is still on its way to us. We are, in a sense, looking at ghosts, beautiful, luminous remnants of a past that no longer exists. That means when you step outside on a clear night and look up, some of those stars may already be gone. Their light is only now reaching your eyes, carrying the last message from a world that has vanished. It's a reminder that everything in the universe is temporary, even the stars. So, the signs are there. The slowdown isn't a theory, it's an observation. The universe's energy is dispersing. Its lights are going out, one galaxy at a time. And yet, the story isn't over. To see where it leads, we have to imagine not just the stars and galaxies, but the very shape of time ahead. In the next chapter, we'll step into that far future trillions of years from now when the last stars burn out and the final shadows fall. What will the universe look like then? And will anyone or anything still be there to see it? Chapter 4. The Far Future. A cold, dark universe. Imagine a clock ticking not in seconds or years, but in trillions of years. The hands move so slowly, you can't see them shift. Yet, over this unimaginable stretch of time, the universe changes beyond recognition. Right now, we live in a golden age of light. Galaxies shine, stars burn, planets orbit. Life, at least here on Earth, thrives in the warmth of a nearby sun. But this age is temporary. In the far future, the last great bursts of star formation will fade away. The brightest galaxies will dim as their remaining stars burn out. Red dwarf, small, long-lived stars will be the final lanterns of the cosmos, burning faintly for hundreds of billions of years, but even they will eventually exhaust their fuel. When they do, the night will become deeper and darker than anything we can imagine. Planets that once circled warm stars will be left adrift, frozen and alone. Without the heat of a sun, they will be silent spheres of ice and rock, wandering through space with no destination. In this era, the universe will be filled mostly with stellar remnants, white dwarfs, neutron stars, and black holes. White dwarfs will cool over trillions of years, their glow fading until they become black dwarfs, cold, invisible husks. Neutron stars will remain as dense, dark points. Black holes will dominate the cosmic landscape, swallowing anything that drifts too close. Even black holes, however, are not eternal. According to Stephen Hawking's theory of Hawking radiation, they will slowly leak energy over unimaginable timescales. The largest black holes may take years to evaporate. That's a number so large it defies ordinary comprehension, more than 100 zeros long. But eventually, even they will disappear. By this stage, the universe will have entered what scientists call the heat death, or big freeze. This isn't a dramatic explosion or collapse, it's the quiet settling of everything into a state of maximum entropy. There will be no energy left to do work, no gradients of heat and cold, no motion except for the occasional subatomic particle drifting through the dark. The temperature of the cosmos will approach absolute zero. Time will still pass, but nothing will change in any meaningful way. The universe will be, for all practical purposes, dead. It's hard to picture such a place. No galaxies, no stars, no light. Only an endless black expanse, dotted with the last fading embers of creation. It will be silent not because there's no sound, but because there's nothing left to make it. And yet, in its own way, this vision is strangely beautiful. The universe began in a blinding flash of creation, expanded into a tapestry of light and color, and will one day fade into a calm, quiet darkness. It's a story with a beginning, a middle, and an end. Some scientists have wondered if this truly is the end. Could something new emerge from the cold remains? Could quantum fluctuations spark another Big Bang, creating a new universe from the ashes of the old? We don't know. If it happens, it will be far beyond the timescales of human or even stellar existence. For now, all we can do is imagine. When you stand beneath the night sky today, you're looking at a snapshot of a living universe. The stars above you are part of a fleeting moment in cosmic history. In the vast timeline of everything, we are alive during the briefest flash of light. This knowledge doesn't have to be bleak. In fact, it makes our place in the universe feel even more precious. Out of all the moments in eternity, we exist now when the sky is still full of stars, when light still travels freely, when warmth still reaches our skin. In the next and final chapter, we'll return to the present and ask, knowing all this, how should we live? What can we do with the brief window of light we've been given? And why, understanding the universe's fate, might make us value our fragile world even more. Chapter 5. Why this matters to us now. We've traveled billions of years into the future, watching stars fade, galaxies grow cold, and the universe falls silent. But now we return to the present, to this brief, shining moment we call now. Right here, right now, the universe is still alive with light. Stars are still being born. Galaxies still spin. Our sun still burns brightly, pouring warmth onto Earth. We live in a cosmic springtime, rare, fragile, and impossibly brief. Knowing that it won't last doesn't have to fill us with dread. Instead, it can deepen our appreciation for the moment we are in. Every sunrise is a gift of stellar fusion. Every starlit night is a reminder that we live in a time when the sky still glows. Think about it. Out of the universe's entire history, the conditions for life as we know it exists only for a tiny fraction. And yet, somehow, we are here. We are conscious. We can look up, wonder, and try to understand where we came from and where we're going. This perspective changes things. The petty worries of our day shrink in the face of cosmic time. The conflicts and noise fade when we realize how rare this living universe is. It doesn't make our problems disappear, but it reminds us of what really matters: connection, curiosity, and care for the small corner of the cosmos we call home. Science gives us the facts. It tells us the universe will one day go dark. But how we respond is up to us. We can ignore it, we can fear it, or we can choose to see it as an invitation to cherish the present, to protect the fragile world that sustains us, and to keep exploring while the lights are still on. So, tonight, if you find yourself under a clear sky, take a moment, look up, find a star, any star, and remember that it's not eternal, neither are we. And that's exactly why this moment matters, because someday, there will be no eyes to see the stars, no minds to wonder, no voices to tell the story. But right now this is our chapter in the universe's book, and we get to write it. If this journey through space and time made you see our universe a little differently, consider joining this channel. A like, a comment, a subscription, they help keep the conversation alive. Share what you felt, what you wondered, or what you'd like to explore next. The stars are still shining. Let's keep looking up together.